Hey, what is up everyone? It's your boy Fahad here, and this is part 2 for my stat final review video. Hopefully you guys enjoy it. Just be sure to, pause the video, try to attempt the problem on your own, and just continue watching it when you feel like you got your answer, and then you could just check it. This video, the problems are quite easy. Part 3, I'll most likely be going over moderate to difficult problems. But overall, I just want to get through all the learning catalytics, and if people like it, I'll continue to make more videos. Let me know, and without further ado, let's get straight into the video. The scatter plot shows what type of relationship between median age of marriage for men and women. Over here, since it is going upwards, and this is a positive association. If our scatter plot was if our dots were further away from each other, kind of like I'm drawing right now, this would be weak. However, since these are very close together, this is going to be strong. So the answer choice would be D. For a certain group of cars, there is a strong association between city and highway mileage that can be described by the equation. So this is y equals a plus b, and this is our x. So to solve this, we legit plug in 35 for our x. So how it would look like is, then we would do plus 0.95 times 35, which is going to give us 41.04. So this is our answer, A. Do people who run at least 5 miles a week have a higher resting heart rate than people who ride their bike at least 5 miles a week? People were allowed to participate in only one sport. The resting heart rate of 200 runners and 200 bikers who cover more than 5 miles were recorded. To answer this question, would you use proportions or means? And dependent or independent samples? So first look at whether it's a proportion or mean. Over here it says at least 5 miles a week. So we're given essentially numerical data, and if it did say something like, the average number of miles a week or something like that, then it would be means. However, this is a proportion. So it's not means. And let's see if it's dependent or not. So essentially, we have 200 runners, 200 bikers, and they're independent from each other. So that's why the answer would be 2 proportions from independent samples. So we're independently basically looking at the bikers and runners. The school has 2 kindergarten classes. There are 21 children in class 1 and 17 of those are defined as pre-readers. There are 19 children in class 2 and 13 of those are defined as pre-readers. 90% confidence interval for the difference in proportions was determined. Which of the following statements is correct? Okay, so let's look at option A. Let's just take a look from a general perspective. If 0 is captured within the interval, within the confidence interval, that does mean that there is a similarity between the 2 proportions. If it's not captured in it, there's usually a disparity between those 2 proportions. In this case, we're going to really want to take a look at the sizes of the samples. We do have our sample sizes are too small, and as a result, that's not really accurate as well. So this is one of our options. The confidence interval is is no accurate because the two samples are not random. So this also holds true. This is because so we're talking about classrooms, and classrooms are not really random. It doesn't really say nothing about a random design at all. So if it mentioned anything about SRS or simple random sampling, those two conditions would be helpful in proceeding with this problem. But since those aren't really satisfied, the correct answer would be E. A candidate from the U.S. Senate wishes to compare her support among voters in the northern and southern halves of the state. A random sample of 2,000 from the northern half of the state is selected, and 1,062 support the candidate. All right, let me highlight that. A random sample of 2,000 from the southern half is selected, and 900 support the candidate. Calculate an estimate of the parameter P sub n minus P sub s. So what is Pn? So if we look over here for the northern half, we have 1,062 divided by 2,000, which will give us 0.531 if we put it in our calculadora. And let's do P sub s, which is 900 divided by 2,000, which gives us 0.45. So now what we need to do is just subtract these. P of n minus P sub s. This gives us 0.081. So this is our answer, C. So this is the same as the previous problem. We're just checking if the 95% confidence interval, if it contains 0. So if it captures 0 or not. Does it capture 0? Does it not capture 0? So we look over here. It does not capture 0, so the answer is basically B. But let me just explain what they mean. So if it does capture 0, that basically goes to show that essentially that our proportion that it does not have like a difference between the proportions. However, if it does not capture 0 within the confidence interval, that goes to show that there is a disparity between the proportions. So that's just something you should keep in mind. And yeah, just check the confidence interval and see if it captures that value.